Here we are showing the temperature sensor. It's starting in Celsius, and as we put our finger on the temperature sensor to warm it up, the value changes. Here we're switching to Fahrenheit, and as we also heat up the temperature sensor in this case, the value for the Fahrenheit also changes.
Here we're changing the mode to the counter, which is the stopwatch. The button starts and stops the stopwatch, and the second button pressed resets it.
Here we are showing the ALU functionality. We're toggling the mode to show the adder, and now we're changing the A and B values, showing that the ALU works for the adder function.
Here we're changing the mode to 1-1, which is just a placeholder.
All of our modules are combined in this combine module, which takes in the inputs and outputs from each module that we're calling. We call the top module the counter, our 7 segment, which stems from our ALU, and the say hello, which is just a default for the fourth bit when it's 1-1. And then each case is based on the value of 2 switches, which is a 2-bit switch. The top module calls from I2C, clock gen, and 7 segment to get our temperature readings and output them to an LED value, and that comes from the 7 segment module, the I2C module, and the clock clock gen, which is right here.
The counter is more of a stopwatch, so this is the main module where everything is connected. There are 3 different modules called under it: the clock divider, the faster clock divider, and the FSM, which is shown down here. The FSM is the main one that we took time working on. When the information is fed into the counter, it comes in hexadecimal form. So this code right here is changing it into binary so that the numbers count up regularly as a stopwatch would instead of in hexadecimal. And in order to show multiple segments on the 7-segment display, this is the code that we had to use for that. This is also the clock divider module. And then in order to make everything perform on the FPJ, this is our master copy. These are the input pins, the clock, the LEDs, the 7-segment display, the 7-segment display with the cathodes and the anodes and the decimal point. That we use buttons for start, stop, and reset of the counter. And the temperature sensor inputs are down here.
Thank you. All right, so why did you decide to work with the counter module?
So originally I was influenced by our TA. He suggested working on it. So we started that in lab, but then I ran into some difficulties getting it to work on the simulation. So that was a struggle. But then once I got it working on the simulation and on the board, it was counting in hexadecimal. So one of my accomplishments was being able to convert it from hexadecimal to binary. Now, Ella, why did you decide to do the temperature converter?
I decided to do the temperature because, one, it was already on the FPGA, so it didn't require any extra parts. One of the challenges I faced with this was getting the right value to appear on the board. We fixed this by changing the I2C code and just manipulating some things. And then one of the successes was changing the DISP switch so that we could switch from Celsius to Fahrenheit pretty easily. So,
Nice.